coming, everybody. My name is Kevin Kempter. I work for Consistent State, and today we're going to talk about ora2pg. I'll do a little bit of an overview. We'll talk about where you can download it. There's some prerequisites. We'll go through a high-level look at the install. We'll spend most of our time looking at the ora2pg config file, and then I'll throw out some ways that we've used it in the past. So ora2pg is based on Perl DBI underneath the covers. You need a working connection, obviously, to both Postgres and Oracle. You can actually run it in a way where you only use the DBI to connect to Oracle, and then it dumps flat files for you, and you use PSQL or what have you to load your data into Postgres. ora2pg will dump the full database schema. You can identify particular schemas, or you can do them all from Oracle. It'll dump tables, views, sequences, indexes. It'll even do stored procedures and functions. However, the stored procedure and function migration is to use their words, a work in progress. So it's not perfect, but it's actually not bad. It's pretty good. We've used it a couple times, and it gets you 80 to 90% there. In fact, the last time we used it, we had to make one change to the code. And it was across the board, but it was in the way that the functions called other functions. We had to make a single change, and everything worked out of the box, which was nice. Likewise, you can export the full data sets for the tables you specify. You can specify individual tables. You can specify a where clause and only dump part of the tables. On and on and on. There's this particular tool has more options than you could believe. We've probably used 10% of the options at best. Most of it at default values works really well. We haven't tested a lot of the, you can do this and that in certain scenarios, but in general, it's a pretty solid tool. So if you wanted to download it, you can get it from SourceForge. Likewise, if you go to the second link here, the ora2pg.darylD.net, that's basically the ora2pg homepage. And there's a lot of good information on that page. It talks, the documentation is out there, the general approach to usage is out there, and obviously the links to jump over to SourceForge and download it are out there. In terms of prerequisites, you need a valid Postgres install, a valid Oracle install, and at least version 5.6 of Perl. Likewise, just as a side note, the Oracle install and the Postgres install do not have to live on the same boxes where you install ora2pg. So you could have Oracle on box A and Postgres on box B, and you could even put ora2pg on, say, box C, and use it to do all your conversions from the same box, which is the last customer we helped with this. That's exactly their plan, because they've got 70-some database servers they're going to migrate, and they don't want to go through the process of installing ora2pg and getting it working on every single box. Do it once and do the migrations from there. Likewise, Perl DBI needs to be installed and working. The DBD Oracle package needs to be installed and working. The DBD Oracle package is a little tricky, meaning it generally works, but you have to fiddle with the parameters a little bit. So making sure that the obvious, the Oracle home is set and the Oracle SID is set and so forth, all the main Oracle parameters. On top of that, you have to point it to the Oracle client libraries. You cannot point it to the Oracle, the server-side libraries. Plus, you probably will have to change the permissions on the Oracle client libraries. So if, in our case, we were running the function or running the tool as the Postgres user on the server. And of course, the Postgres user doesn't even have read access to the Oracle client library directory because those are owned by Oracle. So we had to do some permission resets. Not a big deal. We did a change mod and added R for just read for everybody from the Oracle client library down. and everything worked from that point forward. In terms of installation, the download is a tarball, so uncompress it. You CD into that directory, and like any other Perl module, you execute the capital M makefile.pl as Perl, and then run your make and your make install. There is a make test. The make test is pretty involved, and it's fairly difficult to get it to be successful all the way through because of all the different environment variables you need to set for the test. So we actually skipped the make test. We did the make and make install and wrote a quick little test script to make sure that that the DBD Oracle was working to connect to Oracle, and that DBD-PG was working to connect to Postgres, and we were good to go after that. So likewise, once you do the install, it's actually going to give you an ora2pg Perl module in your Perl site repository. In user local bin, it's going to give you an ora2pg binary, and it creates a etc directory. In the directory, you uncompress your tarball, and it puts an ora2pg config file in there. The ora2pg config file can live anywhere because you specify it on the command line when you execute the tool. So the config file itself is significant in size. We'll go through some of the key variables, but I haven't covered all of them. So one of the most obvious sections is the Oracle variables. We need Oracle home, we need the Oracle DSN, the username, and the password. The Oracle DSN, if you specify it like we have here, DBI:oracle, host equals host, SID equals SID name, that works about 50% of the time. It depends. This is completely dependent on how they've configured Oracle on the Oracle side. So, for example, in a number of the servers we converted, we had to specify it as leave off the host and specify the SID as host name at sid.schema, sort of thing. Most Oracle DBAs are pretty familiar with the different syntaxes for connections. The different syntax you would use for a DSN, an Oracle DSN connection string. And if the Oracle DBAs that you're working with, assuming there are some, if they can give you a command line version of how to connect to the Oracle database, you can basically plug that in as your connection string and it'll work. Obviously, the Oracle user and password. There is a user grants variable. By default, it's set to false. If you set it to true, it tells ora2pg that you're not connecting as sysdba or somebody with the equivalent of super user, which means that it'll hit different system catalogs to try to pull the list of information that it needs to build to generate the DDL for you and to extract the data. So we obviously ran as an Oracle super user, as sysdba, so we didn't have to worry about it. But in the case that you don't have that access, you can still leverage this user grants variable, set it to true, and then you can log in to Oracle as an authenticated normal user as opposed to like sysop or sysdba, and it'll still work for most functions. The areas where you're going to run into trouble is if you actually want to pull some of the system catalogs, which in our case, with one client in particular, that was pretty important to them. I'm not sure why, but they wanted to pull the system catalog data as well. Export schema is, again, it's off by default, which basically says export the create schema command. There's a schema name variable, schema equals blah, and if you set that to a schema name or a number of schemas separated by spaces, those are the schemas that are going to be exported when you run the ora2pg tool. Likewise, there's a Postgres search path that you can set. We did not need to tweak this. Everything we pushed went either into the schema, the originating schema, which already had the path, or tables went into the public schema, which is default. Likewise, this type variable is probably the primary variable you would tweak. So ora2pg works by, it looks at this type variable, and based on what you have in here, that's sort of the operation that it's going to perform. For example, if we have table as our type variable, it's going to effectively dump DDL. It'll dump all the create table statements. Likewise, it'll dump the alter table statements, but it won't dump the indexes. There's a separate, actually, my bad, it does dump indexes. Likewise, if you set it to data, it will dump the data, but it'll dump as insert statements. If you set it to copy, it'll dump the data as copy statements, so on and so forth. You can dump views. When you do grant, it dumps all the permissions, sequences, triggers, functions, so on and so forth. Likewise, there's a variable called tables. By default, it's commented out. If you don't specify anything, it dumps all the tables in the specified schema or schemas. Or if you're dumping data, it'll dump data for all the tables in that schema or schemas. However, if you put a table here or a list of tables separated by spaces, those are the only tables that ora2pg will dump. The opposite of that is the exclude variable. So you can say, I want to dump everything except for the list of tables that I give it in the exclude variable. There's a skip function or variable that basically says, I want to skip foreign keys, primary keys, unique keys, so on and so forth. All this will do is say, effectively, don't dump these constructs for me. Dump everything else but what I specify. The data limit is by default set to 10,000. Is that 10,000? 100,000. Which means that each copy statement is going to dump 100,000 rows, and then it'll add multiple copy statements to the file. You can tweak this. Obviously, just be careful about tweaking it too high, because you don't want to force your machine to get into a swapping scenario. It's not so much of an issue if you dump to a flat file and then you want to push that over to, say, a Postgres database server that's a dedicated box, lots of RAM, and run your copy statement from the command line. It's more of an issue if you have ora2pg connect directly both to Oracle and Postgres and do a memory-to-memory migration, if you will. There's a modify struct parameter. Basically, this one says, if I specify a table, I can give it a list of columns, and those are the only columns for that table that it will dump. So if you've got a table with 47 fields, but for the migration, you only care about 2 of them, you don't have to dump them all. You can just dump the 2 columns you care about. There's a replace tables. This one, it's interesting. Thus, I kept it in the presentation, but we never actually used it. You can specify the original table name and a new table name. Effectively, all it does is a rename for you. I can see where this would be valuable, but again, we didn't use it. Replace columns does the same thing. You specify for a table, you specify in the parentheses a series of original name colon new name, original name colon new name, and it'll rename the columns within the table for you. If you specify the Postgres connection parameters, then ora2pg by nature will go ahead and connect to Oracle and pull the data and automatically connect to Postgres memory to memory and push it straight into your Postgres database. If these are not specified or if they're commented out, the default behavior is for ora2pg to dump to flat files or a flat file. And you can control, we'll get into that in a few slides here, whether it dumps to a single file or dumps multiple files for you. The PG-DSN, PG-user, PG-password, standard Perl DBI connection strings. Likewise, you can have a where parameter. So in the examples we have here, the top one where 1 equals 1, or if we put some other where clause in there, we could specify a where clause that applied to all tables, or you could say where and give it a table name, and then in square brackets give the actual where clause, and you can have multiple table names and where clauses separated by spaces. So it'll apply those where clauses only to those individual tables. There's an output parameter. You can set by default, the output is set to output.sql, and that's the output file where it's going to want to dump all its data if you don't have the Postgres connection string variables set. If you set it to output.sql.gz, it'll automatically do a tar-gz it'll do a gzip. And likewise, if you set it to .bz2, it'll do a bunzip. However, you have to make sure that you have the Perl compression, the bzip2 compression package installed. By default, Perl knows how to do gzip, but it doesn't know how to do bzip2. If you decide to specify bzip2, then you also need to specify the path to where bzip2 lives and the bzip parameter. Likewise, the output directory by default is going to be your local directory, wherever you run it from. However, if you uncomment the output dir and set it to some directory, that's where all your output files will go. There's a number of parameters that allow ora2pg to try to defer constraint checking. So there's an F key deferrable, which will defer all foreign key constraint checking. And there's a defer F key option that defers all foreign key constraints during a data dump. I'm not exactly sure what the difference is, but it's nice that they have the ability to defer the constraints, because if not, you get into some odd situations. Likewise, and we'll cover this a little bit later too, there's ways that you can tell it to separate everything. What we did, just to jump ahead a little, is we dumped all our DDL to disk, and we dumped our indexes and our constraints into separate files. Then we did all the create table statements, and we would do a manual review of the DDL to make sure it looked okay, and then we run it against the target database. And then when we did the data migration, we would do a direct memory to memory straight from Oracle into Postgres. And that seemed to work pretty well, and it, to be honest, gave the client a really high level of confidence that they had the ability to take a look at the DDL and make sure that everything looked kosher. There's a drop F key and a drop indexes parameter that says drop all the foreign keys before the data import starts, and then replace them after the import is done, and likewise for the indexes. Drop all the indexes when you're doing a copy or a data migration, and then replace them after it's finished, which pretty powerful parameters, because of course we can get better performance by dropping all the constraints and indexes, shoving the data into the database, and then recreating all the indexes. There's a PG numeric type variable. By default, it's set to 1, which says it'll replace the numeric Oracle type with either a big int or an integer, depending on how big the number actually is. And there's certain cases where you want to set that to 0, but in most cases, if it's strictly numbers, then it's a good idea just to let Postgres change it to an integer or to a big int. We found that in 99% of the cases, I think there were 3 instances out of about 1,500 tables where we had to come back and modify what ora2pg had selected based on that criteria. In our case, there were a couple of numbers that should have been big ints that it actually converted to integers. We ran into some issues with that. This parameter, the data type parameter, is basically a way for you to specify the mapping yourself instead of letting ora2pg do the mapping for you. So you can say, I want a date to be specifically a timestamp, or a timestamp without time zone, or whatever you want it to look like. I want a long to come across as a text, and so on and so forth. So if you specify the data type variable, you can specify the mapping yourself. One note is that mapping will be applied to all tables. You can't specify just a particular table unless you go into the tables variable and set it just for a couple of tables and do a run, and then go back in and pull those tables out and put them in the exclude tables list, and then do another run with one with the mapping on your own and one with the ora2pg mapping. There you can set the default language. Likewise, there you can enable the PLPG SQL conversion convention. In this case, we left it at the default, and we didn't have any issues with it. But again, if you look into the documentation, it talks about if you're having issues and your data migration flat isn't working right, and you're running into a number of problems where the data won't load on the Postgres side, then this is one of the options to try, is turn this off. By default, this is trying to make sure that the Oracle dumps become as compatible as possible with not only Postgres, but with PLPG SQL in terms of the stored procedures in particular. There's a files per constraint and files per index variable, which says by default they're 0. So if we were going to do a dump and we were going to dump to flat files, everything would obviously go to the output.sql file. However, if I said file per index and set that to true, then every individual every individual table would get a new file with all of its indexes in that file. And likewise, if you set the file per constraint for any constraint, so effectively you're going to get a table and all of its alter statements in a single file, and then all of its indexes in a single file. So you'll have a propagation of output .sql files named per table name, but it is beneficial in terms of it gives you the ability to have a lot of control over how you do the migration and what order you do the migration and so on and so forth. We found that the tool works really well, but it's not necessarily a good idea to point ora2pg at an Oracle database and just say convert the whole thing top to bottom, because there are small hiccups along the way. Sometimes you need to tweak the DDL a little bit. And the other thing we ran into is if we tried even just for the data migration, if we said do copy statements 100,000 rows at a time and do the entire database table-wise, top to bottom, that we ran into memory issues. So and we'll get into this in a couple slides here, we actually set up a script and we would pull the list of tables from Oracle and we would loop through all those tables and we would effectively run the data migration one table at a time. It was automated, so it was still a single function that the user had to run. However, it was much more effective because it would run a table and then basically exit the loop and come back and run another table, and all the memory issues went away. There's a file per table, which again, like the other parameters we just talked about, the file per constraint and file per index. This one would say when we're dumping either data or when we're dumping DDL, we will get a single file per table. Likewise, there's a file per function, which same thing, every function, if you're going to try to migrate stored procedures and functions, will go into a separate file. We dumped all our DDL in terms of functions and tables into single files. So we dumped all the functions into one file. We dumped all the tables into a single file, but we dumped our constraints and our indexes into a separate file so we could sort of manually control dumping the DDL without any indexes or constraints, do a review and apply that, and then migrate the data, and then come back after we've done a review and apply all the constraints and indexes, and it worked pretty well. Truncate table is just that. It'll truncate all the tables before the data migration. You can set the client encoding if you're having issues, which we actually set this because The last client we did this for was using some off-the-wall encoding that is pretty non-standard. So we had issues, even though their database was set with that encoding, the migration was trying to force it back to a Latin 1, and it just wasn't working out. A couple examples I'll walk through. So again, like I mentioned, we would migrate the DDL first, and we would do that to flat files. Then we would migrate the data, and then we would come back and migrate the functions. So in terms of just a walkthrough of what we did, first we wrote a script that would generate a table list for us. And the script was nothing more than a wrapper script around ora2pg. So we would set the Oracle variables, we set the schema variable, we left the tables to blank, and we set the type variable to show tables, which actually isn't in the list in the comments, but if you read through the documentation, it talks about you can set it to show tables and it will show you just a list of tables. Likewise, there's a show schema variable or value that you can set it to, which will simply dump a list of all the schemas for the Oracle instance you're connecting to, which is a whole nother kind of, because a schema in Oracle isn't really a real schema as far as us Postgres guys think. However, it will give you a list of names that mean something to the Oracle DBAs. So in any case, we had this wrapper script and we would run it. We would execute ora2pg and give it the config file and basically redirect that to a file that contained only the list of tables. And then we would migrate the DDL based on that table list. So effectively, we would set all the Oracle variables, set the schema, would leave the tables blank, and set the type to table. And in this case, we would set the file per constraint and file per index both to 1. So what we would end up with is an output.sql file with all the create table statements. And then per table, we would end up with a file with all of the alter statements and a file with all the create index statements, which made it pretty easy to walk through, do a quick review of the DDL, make sure that it looks appropriate, and then execute the create table portion of it against the Postgres database. So again, we wrapped a little script around this. It would execute ora2pg and it would give it the proper config file. We would send the output to a log in case there's errors, and then at that point, we would go in and manually run the DDL against the Postgres database. Likewise, and we didn't do this, we left the views and the grants and the sequences and so forth as part of the main DDL file, but you can split all those out as well. And then we came back and we would migrate the data. So again, we would go back to that original script we wrote to generate the table list, and we gave it the show tables, and we redirected that, in this case, to a file name called tab list. So after we applied the DDL to Postgres, we would set, in addition to setting the Oracle config settings and setting the schema, in our case we did have a particular schema we were leveraging, and we would set the type to copy, and we would assign the proper variables to the Postgres connection settings. What the script would do is it would walk through the tab list file, and it would effectively on the fly plug the tables variable with the table name one at a time, and then it would execute ora2pg for us. And in this case, we effectively got to do the copy memory to memory. We didn't have to dump the data to disk, but at the same time, we're minimizing our use of memory, if you will, and we found that by doing one table at a time in this way, we didn't run into memory issues, and at the same time, the DBAs that were going to take this and migrate the rest of the servers, they only had to run the one command. They didn't have to go manually tweak the config file and change the table name and manually execute it for all 1,500 tables in the database. They just had to run the one script. It would loop through the tables and migrate the data one at a time. And then likewise, we would execute the shell script that would migrate the remaining DDL, i.e. the indexes, the alter table statements, and so forth. And then as a last step, we came back and did the function. So we We went into the config file and created a separate config that had the type set to function. We set the file per function to 1, so we got a separate file for each function. And it gave us an opportunity to review those functions before we executed them against the Postgres database. And we didn't dig too much deeper than that. However, there are variables that allow us to dump procedures and triggers separately. We dumped the procedures and triggers as part of dumping the initial DDL, i.e. we dumped the triggers as part of dumping the table statements, or we appended it to that file. And then we dumped the procedures as part of when we were dumping the functions, and ora2pg, of course, converts those to functions because Postgres, native generic Postgres, of course, doesn't support procedures, it supports functions. In our case, it worked out great. There were no particular issues in their application that required that caused the fact that we no longer have a procedure or a package. We didn't have any issues with those now being functions not really working for the app anymore. I could see where there might be some scenarios where code would have to change if you were leveraging the true Oracle package syntax. In this shop in particular, in fact, both times we've used this, we didn't run into that. So apparently, I don't know how widespread the use of that syntax is. Apparently, it doesn't seem to be all that wide. So if the call of the procedures and the packages and the functions are basically what a typical DBA would do, sort of ANSI syntax style, where you call the individual functions within that package in the application, then this should work out of the gate. If not, there will be some application code that needs to change. And that's kind of it for ora2pg. It is a big tool. I would recommend you take a good look at the config file, read through all the comments in the config, read through the README file. There's a lot of information. This tool has more flexibility than you could imagine. And you'll probably only use 10% of it like we did, but it does work quite well.